Everybody is requested on my YouTube channel on the topics of B tree. What is a B tree and insertion of the B tree? B tree is balanced tree, MOA balanced tree, multi-way balanced tree. It is balanced tree on the ground of the height, that every leaf node have the same length, same height of the B tree. And height is a dependent, height is a function of time complexity. If time complexity is required to reduce, then height should be reduced. In this purpose, B tree is the best, or in my opinion, B tree is the best indexing purpose is used in almost every relational database management system. We store data as a disk, and also disk is related with the main memory. When any data is required to access, CPU give the permission to the main memory, and main memory access data from the main memory access a location of the specific data from the disk. And this specific location node is relayed to the main memory, and then CPU access the data. So this indexing is organized or accumulated by the B tree. B tree access data from the B tree access the node. B tree root node is already identified by the main memory. So B tree is a tree where it is called also a fat tree, because so many children of this tree is organized. According to the length, the number of children is high comparison to the other tree. So B tree is almost a good indexing purpose is used in almost in every database system. Now, height of the B tree related with the children, of course, but their height is the comparison. Height is the from root level to the leaf level, and this height, the increasing of the height means time complexity will be greater. When any node is inserted at the root position of the B tree, because any node, when we want to enter at the B tree, it is first compared to the root node, and then it entered at the leaf node. Node should be entered at leaf node, and comparison first will be started by the root node. And root node is only node where minimum 2 children can be required to obtain. So minimum 2 children, maximum children of M. M is the order of the B tree. The root node is the only node where minimum number of children must be there, that is number of 2 children, and maximum number of children is M. And other nodes, that is except the root node and except the leaf node where no children is allowed, intermediate node, minimum number of children is M by 2. Maximum number of children is M. And minimum number of key is in other cases is M minus 1. And minimum number of key, M by 2 minus 1. And maximum number of key is M minus 1. So if M is the order, then M is the children, then M minus 1 is the key, maximum number of key. And minimum number of children is M by 2. Minimum number of key is M by 2 minus 1. Minimum number of key of the root node is 2. Leaf node consists no children. But some pointer is there. In each node, there have some pointer. Each pointer gives the information of the block, also the data, etc. And this pointer also exists in the leaf node also. But the value of the leaf node pointer is null, because no children at the leaf node is existing. So the leaf node is an important part where it indicates the block of the data. And this type of tree, that is B tree, It is a balanced tree because when we enter data at starting from the comparison, starting from the root node, the comparison, what is automatically compared by the others node, and data is arranged at ascending order. That is from lowest to highest. When any data is entered at the B tree, any node comparison is started by the root node, then if it is a value of the data entered, which will be entered, is value less, then it will be shifted as the left position, and if the value of the data is higher, then it will be shifted as the right position of the data. So comparison starting from the root node, and it is coming to the right node, and it is coming to the lowest position, that is leaf node. Data is entering at the leaf position, leaf node, but extension is going on towards upwards. Always extension is the upwards. So if we want to compare, if we see that X is the data is required to enter at the B3. Suppose there are B3, order is M and keys will be M minus 2. Order is M equal to 4, key should be 4 minus 1, that is 3. So X is the number where I want to, X is the key I want to insert at the root node. So X will be compared. Suppose the value of the key, first key 1, K1, K2 and K3. X will be compared K1, and another also there another parts will be there at the for the record part, for the record. K1, K2 and K3. 3 keys there. X will be compared K1. If X is greater than K1 and less than K2, then X will be shifted at this node. And this is suppose at this node it will be shifted. And if X value is greater than K1 and less than, so if the value is greater, always the key will be shifted to the right position. When the value of key is greater than existing key value, then it will be shifted to right of the key. So X, the value of the X is greater than K, then this will be shifted to the right of the K. Opposite way, if the value of the greater less than K, it will be shifted to the left position of the K. This is the, so there are some, this is the one position, this is left of K1, right of K1, this is right of K2, and this is right of K3. This K, this X, value of greater than K3, X3, suppose it is X4. Suppose X4, value of X4 is greater than K3. Value of X3, X2 and X1. Value of X3 greater than K3 but less than, greater than K2 or less than K3. X3 greater than K2 and less than K3. X2, value of X2 greater than K2 and less than K1. Value of X1 is less than K1. This is the arrange, and this is alphabetical order. You can say the ascending order also. So when the data is entered, any node, any key is entered at the node, automatically it is taking position by ascending order. If the node, if there have no position to enter the node, then this node will be splitted, and this splitting will be done mainly at the leaf node, but any leaf node also. So now we want to see the splitting. Splitting of node. Suppose the order of the B tree is 3. Order is B tree. Suppose C, 4. That is more nodes we can enter at this position. If the order is 4, then number of key is 3. So number of key is 3. So there are another, suppose this is the key 10, 12, and 15. 3 keys of this node is showing. And if we want to split another, if we want to enter another node, that is, I want to enter another node, that is 20. No provision to enter the node as the 20. So I am showing a dotted line. Now I have to split the node, and this splitting will be done by middle way. And these 20, taking the node 20, that is a coming node, taking the node 20, I am splitting the node. I am splitting this node. And after splitting, two dividation is, two node group is there. One is 10, 12, another group is 15, 20. After splitting, two group is already organized or originated, but the middle node, there are some middle node. If there are 5 nodes, so I can identify one middle node, but it is an even number of nodes, so we can't identify the middle node, but we have to identify the middle node. What way I can identify middle node? I can identify middle node. 2 middle nodes is I can identify. One is 12 and 15. Taking 2 nodes, 12 and 15, we can identify a group of nodes that is middle node. But one node we have to identify. Identify by 12 is also we can identify 12 or 15 or any one I can choose as a middle node, left biased or right biased node. We can identify only one node, and which node, the node which will be identified, it will be serially, this phenomena will be serially going on. So 12, I am identifying the node 12. So 10, 15, 12 will be vanished from this position, and 12 will be shifted here, and after shifting 12, the splitting 10 and 15, 10. Though there are, so there are two splitting. The splitting is done, two group is organized or originated, and left node is identified 10, another node 15, 10 is identified a right side node. At the right side node showing greater value, left side node showing the less value. And this is the splitting, and splitting is done upwards. Splitting is done at specific position of the node and moves upwards. So this is the splitting, and the new node is entered at the B tree. So always splitting will be done and extension will be at upwards. So this is the rules of the B tree. If we want to enter 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, that. Now we want to enter the normal number or 1 to 10. First, I have to sketch the node, but what is the order of the node? Suppose the order is M. If the M is the order, then children is M. Key is M minus 1. Minimum key of root node is 2. Minimum key one root node must contain 2 minimum child nodes. So this will be the child node. Key is m-1. Minimum children of root node is 2. Minimum children of the root node is 2. And maximum children is m. That is, order is m, maximum children is m. And minimum children of node except root node is m by 2. Minimum children, of course, half of the children. Its order is m, maximum children is m, minimum children is m by 2. But if order is m, if the order is m and maximum children is the m, minimum children is m by 2. If order is 5, then 5 by 2, there is 2.5. What value we have to take? We have to take the true value, that is ceiling value, not floor value. I think this value we have to take. So we have to take the ceiling value of the 2.5. So this is 3. So minimum children is m by 2. Minimum is m by 2 minus 1. Now I have to enter the value of the from 1 to 10, and order is suppose 4. So order is 4. So minimum key, maximum key, we can arrange here 3. Key 4 minus 1 equal to 3. C key. So we have to enter now value. And this is this partition is showing the record pointer. And now we have to enter the value. First value 1. And when we are going to enter the value, we have to see the comparison. First value will be entered at first position, that is left position, that is 1. Second value, we are going to enter the second value 2, and this value will be compared to 1. If the value 2 is greater than 1, then this will be take the right position up to 1. And second 3, also it is easy because it will be take also right position of the 2. So this is the 1 to 3 is complete. Now 4, but no provision is there to enter the number 4. So we cannot enter the value of the 4 here. So what is the provision? What is the rules? Rules is I have to split the node and the middle value will be detected. This splitting will be done taking the number 4, not separating the number 4. Taking the number 4, we have to split this node. So after splitting, the splitting 2 group is already originated. One is 1, 2 taking, one is 3, 4. And middle position is detected 2 because it is the left. I have taken the left value of the position 2 of the node. So 2 is shifted at upwards. So 2 will be shifted at the upwards and taking the root position. Another node is 1, that is left node of the 2 will be shifted as the left position, and also 2 already shifted to the first position, root position, 3, 4, and this 3, 4 value of the 2 is showing at the right position of the node. So root position containing only one node. two provision is there to enter the value. And also here also left position of the node also showing the two position of the key, and there are also one position. Now the next value is coming 2, 3, 1, 2, 3, 4 already done. 5, fifth 5 will become 5. Where this number put it? So first we have to enter. First we have to consider. We have to compare this root node with this node, and showing that two value 5 number is greater than 2. If it was less, then it will become at this position. It is greater, so it will come at this position, and it will also compare the existing value and showing it is take the position right position. We know that the value is greater, we'll take right position. Value is less, we'll take left position of the node. So 5 already occupied. 6. Next number 6. But left position never it will come at this position, and also not here, but because the insertion will be done at the leaf nodes. So always it will come at this node, and but there are no provision to enter the value of 6. So what we have to do? We have to split the node. This splitting, get two groups. One is 3, 4, another is 5, 6. After splitting, two group will be created, but middle value will be detected. We have to enter, we have already detected middle value 4, and 4 will be shifted at the root position of the node. So 4 is coming here, and two group, one is 3, another is 5, 6 is already created. This 5, 6 is greater than 4. So this will come at this position. This is the final position of the root after entering the value 6. Because 6 is 5 is greater, so it will take a right position, and also it will take 3 is less than 4, it will take less position, and also it is in between the value of the 2 and 4. And 1 is less than 2, so it is we take the left position of the node. Now the next value is coming 7. 7, same way we have to compare with the node, root node. A root node saying that the value will go at the right node, rightmost node of the node. So this will take 7 will take this position, right position of the 6, because there are some provision also to enter the value of another value, because one portion already vacated. Second value, next value is 8. Where it will be go? Next value 8, greater than 4, greater than 7. So no doubt it will come at this position, but no provision of the to enter the value. Similarly, we have to split the node. This node will split it in two groups, 5 and 6, taking one group, and another is 7, 8. But middle point is 6, because we have only taken left bias value. So 6 will be taken. So this value will be shifted to the will be uplifted. Uplifted means it will be adjusted at the position of the 4. So 6 will goes to this position, and next figure is there. Two, 4, 6, and one is 1 bracketed 3. 3. And another value is 5, 6, and 6 already shifted. So 5 and 7, 8. 5 and 7, 8. 5 is greater than 4, that is, it is a right child. 5 is greater than 4, so it is a right child. And 7, 8 is the greater than 6. So this will be the right child of the 6. This is the position after entered is the value of right 8. Now 2 values due, 9 is coming. 9 after coming 9, easily it will come at this position because it is the right position of the take the right position of the 8, and now 10. Similarly, similar way, this is required if you want to enter the value of 10. This will be split in two groups. One group is 7, 8, and is 9, 10, and middle point is detected 8. Middle point value of the will come at this point, will be shifted and will be take place at this position, at a root position, and two group will be there. So if the 8 comes at this position, this will be also splitted because maximum number of key is already taken. So there are some middle value. Middle value is 4. Middle value 4 will be shifted here. So 4 is already at the top position. Root, now root is 4, and the two children of the 4, that is 2. One is 2. Another is 6, 8, because 6, 8 is already entered, and 6, 8. So 6, 8 is greater than 4. Okay, this is the position of the 6, 8. Now 2, one child of the 2 is 1. So 2, one child of the 2, that is 1. And 6, 4, already 4 have 2 child. 3, 5. 3 is less and 5 is greater than 4. So 3 will be shifted at the right position of the 2. 5 is another child, and 5 will be shifted to the left position of the 2. And there another note is there, 2, 3, 5, 2, 3, 4, 5, 4, 5, 6. 5 is the left position of the 6. Five is the left position of the 6, and 9, 10. 8 already shifted here. 9, 10 is another 2 nodes. Will take the position at the right position of the 8. So 1, 2, 3, 4, 5, 6, 7. What is the 7? This will be a 7. So 7, 8, 8 already shifted. 10, 9. So 7 is the child of the right child of 6. Seven is the right child of 6, and 19 is the right child of 8. So this is the final position of after entering the value. 4, 1, 4, 2, 3 is the left position of the 4, and 4 is the greater, 3 is the greater than 2, right position of the 3, and 6, 5 is less than 6, then is left child, and also 8 have 2 children. If left children is 7, right children is 9 children, because 2 is greater than 8. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. This is the final position of after entering the value of the up to 10, from 1 to 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So insertion of the B tree is a process where each node is splitted. If the havoc position is obtained, then node will be splitted, and new node will be a new position of the node will be at upwards, and node split at lower position, and adding node at what position, but will be moved towards the upwards, or not horizontally, it is vertically. Vertically movement will be there, increasing of the vertical. And in this way, the indexing is done, and it is called automatic indexing because the indexing or arranging is done automatically. And length is short, but children is more. So height is minimized. And height is minimized, minimum height, then the searching time will be less. So this is my end of the video, and please subscribe this channel for latest video.